And we will now move on to the second part of our workshop. We'll get started with the mechanized project on sugarcane in the northwest region of Argentina. We will talk about the keys of the future of sugarcane plantation. We will have three speakers. First, Juan Giardina from the Agricultural Sugarcane Subprogram of EEAOC. He will then give the floor to Juan Vallejo, the Agronomical Management Section of Sugarcane of INTA Familia. These represent the two research institutions that joined us during the project, and this session will be finished by Esteban Brito from Los Balcanes Sugarcane Company. He is member of Yungas CREA. Before I give the floor to the speakers, let's watch a video that it's a theme video on this project, so you are better introduced to the subject matter.
En CREA nos proponemos aportar a la mejora continua de nuestras empresas y de nuestro entorno. Asumimos los desafíos que nos presenta el agro en un contexto político, económico, social y tecnológico cambiante y demandante. Identificamos las demandas y por ello investigamos. Así es que trabajamos en equipo y de manera interinstitucional en diferentes proyectos. Hace 3 años decidimos evaluar y generar conocimiento sobre la última innovación y revolución tecnológica para el cultivo de la caña de azúcar, la plantación mecanizada. Lo hacemos con estrecha colaboración y en conjunto con las instituciones de investigación agropecuaria más prestigiosas de la región, INTA Familia y Estación Experimental Agroindustrial Obispo Colombres.
Realmente me pareció muy importante la vinculación entre diferentes instituciones, tanto como el INTA, CREA y Estación Experimental, el trabajo conjunto, miradas distintas y un enfoque nuevo, esta nueva tecnología de aplicación que es la plantación mecánica de caña de azúcar.
Sin lugar a dudas ha sido la forma de profesionalizar esta tarea, que es muy importante dentro de nuestros cañaverales. De esa manera poder medir y tomar decisiones con criterio.
Fue sumamente importante porque nos ayuda en el desarrollo de lo que es la plantación mecánica, tanto en la parte agronómica como en las aplicaciones y el resto de otros productos. Nos colaboró mucho en el ensayo de la disminución de la yema por metro, del desarrollo de la caña y en distintas condiciones de suelo en todo Tucumán.
Vamos puliendo algunos detalles que no teníamos en cuenta y bueno, estamos planteando una serie de ensayos más para años sucesivos.
Nos propusimos evaluar la eficiencia de la plantación mecánica en diferentes escenarios ambientales de Tucumán y sus efectos en la productividad de los cañaverales. Y esto es lo que hoy venimos a compartir.
Good morning to you all. Thank you for inviting me to take part in this presentation. I'm Juan Giardina. I'm an engineer. I work in the Colombre group. I work in the agronomy program of sugarcane, in the agricultural program of sugarcane. And in my presentation, I'll talk about the project of mechanized sugarcane planting, CREA NOA region, the keys to the future of this planting. I'm joined in my efforts by agricultural engineers that are mentioned on the bottom of this presentation: Duarte, Medina, Fajre, Barceló, Perez, Di Gonzelli, and Eduardo Romero, who is our head and our director whenever we perform projects and efforts. So we were faced with the need, based on this new technology, for implementing this new planting method. We were faced with the need to create alternatives. This is why, with different companies from our environment, with a group of growers, we faced the need to create a new project. The purpose was to create a network of tests to generate mechanical planting on the different environmental scenarios and what their effects were like in productivity. The specific purposes that were considered were to assess growing on the different sugarcane planting areas, as was presented by Manuel Ponce before. We have 3 to 4 sugarcane growing areas, and we were bound to see what the behavior was like of this new system, of this new technology, considering the productive impact of our sugar plantations. Then the stages, both the seed beds, the harvester, and the transportation, the damage that was suffered by the bud that was being tampered with. Also assessing the mechanical planting in different time seasons and considering different growing densities. Traditionally speaking, we implemented manual planting methods. And finally, we assessed criteria to decide the timely moment of dirt removal, this being very essential, and that is a cultural task to remove outgrowth, to remove dirt. We are placed in a subtropical area with a dry season, and this brings about its own limitations for the development and the performance of sugarcane as a plant or as we wanted to give the scenario of the sugarcane region in Tucumán. It is on this area of the Chaco-Pampean grasslands and the foothill area. We have a number of different environmental scenarios in our region for growing sugarcane. This is an extensive region that encompasses, give or take, 276,800 hectares. That is, we have a number of different environmental scenarios, so to speak. We generally have 3 planting or 3 growing seasons, but the one that is used for developing this technology was autumn, winter, ranging from May down to August, and planting in springtime from September down to October. There is a summer planting season from February down to March, but regularly speaking, this shouldn't be the chosen season. Considering the main lines of this project and the stages to assess, we considered 3 of them. A pre-planting stage, where it was a matter of choosing the plot of land to assess the behavior of the seed at the various stages of the process, that is, in the infill dumper and considering the planter. Secondly, we had to assess the planter in and of itself, that is, its performance, its yield, its work, and its quality for developing such a system. And finally, and on a third stage, we focused on the planting itself, the cultural typical activity, the purpose being to uniform the sprouting and the stalking of the buds when harvesting sugarcane, later to establish a good foundation, considering factors such as sprouting and other failure and production estimate considerations. As can be seen on this slide, this was initially pre-planting. This is where we chose the plot of land, the harvester type, the types of loading, the sampling that would be carried out at the various points, whether at the harvesting, at the infill dumper, or at a planter stage, to see what the different impacts would be pre-planting wise. The selection of the seed beds, uniformed parameters, these criteria were kept under strict and rigorous protocols. All the data that we will be presenting resulted from a protocol that we agreed upon with various institutions, CREA, INTA, among others, in order to standardize or uniform the designs around how we would assess under this new system. On the seedbed plot of land, we had to take care of distances so that seedbed lots would be 3 to 5 kilometers away from each other in order to render an efficient supply of sugarcane seeds down to the planter. We also had to focus on the sanitary condition, that there would be lower RSD levels than 2.5%, and the yellowish color, that is the sanitary status of the seedbed lot, is an important condition to consider. There should be less than 10% damage by sugarcane borer or Diatraeria sacchalis. This could be some sort of damage because there's a furrow that this is produced by the borers on the stalks. These are gateways where pathogens come into the plant and they dehydrate the material. We use plant cane, ratoon cane type 1 with a good nutritional condition so that there should be no deficiency symptom. The cane should not be fell, it should be upright on its stalk, because this should help homogenize on criteria that have to do with the choice of the seedbed lot. And the variety, as was stated on the previous presentation, was LCP 85384, one of the most widely spread varieties in our province. It accounts for almost 80% of catchment in the productive sector. Well, if we focus on the data now, in the first few years, we assessed damage that could happen, keenly so when using mechanical harvesting methods. Even though a number of modifications ensued as a result of our experience, we see that more than 30% there were damages in more than 30% of cases. There were damages on buds. Buds had been damaged, and these buds would no longer be of any use as a source or as an input for the sugarcane facility. We also see on the upper hand right chart, in the case of infield dumpers, damage is 4%, and in planters, damage is relatively small, where we have around 1.8% damage. If we accumulate the total damage during the first year where we assessed, this represented or accounted for almost 38% of buds that were lost to the process when planting them because of the effect of mechanical harvesting. This data got repeated in 2017 as well as in 2018. And on the lower left-hand chart, we can see how this damage got reduced. Different types of methods were used. The speed at which the harvesting took place came down from 2.3 kilometers per hour down to a smaller rate. Chopping blades were removed. We used some dumping methods. And we also see how we could assess in the harvesting at what point or at what piece of the machine did we find the greatest amount of damage. Initially, when the cane comes into the machine down to the dish, that accounted for 89% of damage. On the second red circle, on this part of the machine, we assessed how the damage was like by tracing the material behind. This represented another high percentage. In this case, we did not see any damage on the infield dumper and only 1% damage in mechanical planting. So this kind of shows a total in 2019 of 30% damage, give or take. That is to say, there was a reduction by 8 or 9% of mechanical damage at this point of this sugar cane. we should consider that harvesting cane for planting does not compare to harvesting cane that will then be ground. We have to consider the vegetable that is at the bud. This is what will yield a new plant when we plant again. Other assessments that were observed out of the buds, qualitatively speaking, out of the buds that we saw that were healthy, we had them sprout in sprouting chambers under controlled humidity and temperature conditions so as not to give them any limitations. And we see that on the first graph to your right, we see a decrease. This happened during the first year, that is in 2017, how on the seedbed lot we have a potential sprouting of around 95% of the buds that we wanted to sprout. And there is a decrease in the sprouting potential coming down to the mechanical sprouting with a 20% reduction. And this damage we considered unavoidable damage. That is, qualitatively speaking, we could not sort it out, but there was some sort of invisible damage, so to speak, that had an impact on the buds, and that caused losses in sprouting on buds that were placed on the furrow that would not really sprout. This trend came down, the invisible damage got reduced by a number of modifications and tampering or regulations actually in the harvest. We see that that was brought down by 10%. I also wanted to compare vis-a-vis manual planting. This is the graph on the lower left-hand side. We see the seedbed, 94% sprouting, and on manual planting, 91%. That is to say, when we handle the bud and having the bud go through all the mechanical stages involved when planting, well, that caused some sort of invisible damage that had to be necessarily considered as a factor in order to optimize planting density. Other assessments that were carried out considering the quality of the harvest and factors to consider, these being very relevant parameters. They were given by the quality of the cut. We would classify them into good, regular, and bad. A poor cut can be seen here. The good cut is a net cut, a flush cut. This helps avoid any pathogen entering the cane. It avoids dehydration. Irregular cuts have some flaws to them, and we have to consider the use of blades. Blades have to be brand new. We have to turn them around as quickly as possible in order to avoid any conceivable damage, because this is what will be underpinning the bud initially in its initial stages. And then we have a bad cut that it's kind of frail. And this, of course, caused the buds to go dry, and it helps the stalk be invaded by pathogens. It's important to say that another factor has to do with the classification of stalks, whether they are good, whether they are cut, or whether they are scratched. We have some impact on the rollers that impact the harvest, and they may have a negative impact on the stalks. And this will have a noticeable impact on how the bud may blossom or not, and on our plantation as a whole. This is why we see that we have to be really careful, and we saw that how we regulate the harvesting machine has a lot to do, on how the seed sugar cane is taken care of has a lot of impact at the various planting stages.
I would like to show you as well that there are certain issues to be considered which are very important, and these are given by the uniformity of the size of the chopping. We have determined in this study is that between 30, we have less than 30 centimeters, between 30 and 45, and more than 45. We see in the slide in the upper right corner a great uniformity of chopping below 30 centimeters, so approximately 25 centimeters, and that's 85% that we had with this quality. This is very important because it improves the performance and the fluidity when it comes to doing the planting per se. This improves significantly the distribution of the furrow, and it also improves the fluidity of the stalks inside the machine, the process itself, and also allows us to better regulate the different densities of plantations. In the slide, there is heterogeneity in the size of the stalk, which was below 30 centimeters was about 50% of the cases, and between 30 and 45 centimeters was the other half. So this heterogeneity of the size of the chopping many times created some problems regarding the regulation of the densities of the population. And that did not allow us to have good versatility in the regulation process. Also, that heterogeneity caused the fluidity to be impeached, and this caused certain inconveniences. In the second stage, regarding the evaluation of the plantation per se, or the planting process per se, we had, in terms of the density of planting, what we wanted to establish is two types of planting density. This is what we had as mechanic commercial, which is between 28 and 30 buds per meter, and trying to reduce this density to reach approximately between 18 and 20 buds per meter. Normally, under other environmental conditions, we would placing between 15 and 18 viable buds per meter allows us to have a good plantation based on the analysis of manual processes and plantations per se. So in the upper chart, in the chart that appears above, the green lines show, first of all, the fact that we established sampling stations with 5 furrows of 5 meters. So we measured meter by meter the number of cane, the amount of cane in each station. And then we counted viable buds, damaged buds because of pests, and because of other problems. And we saw that in none of the stations we were able to achieve the amount of buds that we had defined, which was about 28. So if we analyzed the general average, we did reach that point, but in no points we were able to reach that average in the stations that we assessed. So there is a wide heterogeneity when we analyze a situation. And the same behavior, similar one, was the one we observed when we analyzed lower densities. Although we reached the established average, which was about 20.68 buds per viable meter, we saw that none of the stations reached that average. And in order to reduce the density in the planting and reach these averages, we had a strong influence of the size of the chopping. That was very important to achieve our goal. That's why we decided, although we were able to attain, when we were evaluating and making averages, we were able to attain the goals, which was 28 buds per meter, but more often than not, in the sample stations that we evaluated, we had 22 buds per meter. So the value to be considered as a criteria, this is what we were able to do and use in our evaluations and in the different monitoring processes that we were conducting in our plantations with mechanized planting. And we see how the value of the mode, which was between 28 and 30 buds per meter, the actual one is 22 viable buds per meter with commercial planting, with maximum values of 51 and minimum values of 13 buds per meter. With reduced mechanics, we see that in average we are able to establish 20 buds per meter, but the most common value that is repeated in the sample stations is 16. We have maximum for a 42 and a minimum values that are found of 6 buds per meter. This criteria that was included in the system shows that we need to find the most frequent value that we find when we conduct our evaluations in mechanical planting. Something that must be pointed out, which is very important in the performance of the planter allows us to have high levels of productivity in the depth of the furrow, in average 20 centimeters. We were able to establish a broad-based furrow with good distribution and on both sides of the furrow. And then the establishing of the ridge. This is done through a machine that creates a ridge with a very good finishing. And this involves a series of discs that allows us to establish a ridge which, for our environmental conditions and our scenario, involves a typical work done in an area, very ancestral. So when the ridges are lowered, also this allows us to have a minimum ridge of between 5 and 6 centimeters. And this machine that we are using really allows us to do it very neatly, very homogeneous, and to establish the plantation in the best possible manner. Also, from a qualitative perspective, the distinction of the seed cane. We see here how the evaluation of the mechanical planter is conducted. The cane seed is a very important input in regards the plantation per se. It is a very important input because it is healthy material, vigorous material with high quality standards. That's why in the first year, 2017, we compared manual plantation versus commercial planting. And during that year of analysis, we used a higher amount of tons of seed cane, which accounted approximately for 5 tons more of seed cane per hectare. Why am I bringing this up and why am I mentioning this input? Because seed cane is a very important input and has a strong influence in the costs of planting. In 2018, we see how we adjusted those tons per hectare, and we were able to reduce going to 15.3 tons per hectare to 13.2 and to 12 tons per hectare. We see that with commercial planting, we were able to reduce to 11.4 tons per hectare, and with reduced, almost 10 tons per hectare. So we were almost able to reach levels that are comparable with the values that were used for manual planting. I also would like to mention the fact that we can reduce the levels of planting density, and this has a lot to do with the varieties that are being used, because the varieties that were used here were LCP 85084, which in 1 ton can have approximately between 25,000 and 30,000 buds, as opposed to other varieties which have others like 9510, which in 1 ton can have between 15 and 18,000 buds. So in one same ton, we can have 10,000 buds of difference. It's important to regulate this and take into account the concept of density of planting and evaluate the number of buds per meter and not just kilos per furrow, which is the normally applied criteria. Finally, we see in the chart that the average of the entire season that used 13 tons with commercial planting and with reduced mechanic, the average was 11 tons of tons per hectare. So once again, this new planting system can reduce densities, which in turn reduces the amount of tons per hectare needed to establish very well the system of mechanized planting. Other criteria were the moment of lowering the ridges. This is a very traditional task carried out by laborers here. And during the first year, the concept was that when there was like an emergence above the ridges, we would lower them, which is basically the excess of earth that is placed over the seed. The soil is placed to preserve the humidity, protect it from the cold, and avoid sprouting. So we lowered these ridges when there was 40-50% of sprouting. Sprouting is considered as such when the sprouts enter a phase where they have a size between 2 and 3 centimeters, where they have not emerged above the surface of the soil. This is a stage considered like the emergence of the sprout. So we need to dig and see the amount of sprouting that is occurring, and that's when the lowering of the ridges takes place. This was included into the concepts. It went to 30%, and we did a second lowering of the ridge with 60% of the sprouting. In the mechanical planting system, this is very important because the size of the stems that you place in the furrow are stems that are shorter and more reduced than with manual planting. So we want these stems to sprout in the best possible way and for them to establish so that the plantation is successful. Under this set of criteria, what we did was analyze yield and how the plantation itself was established. In 2019, we established a new set of criteria, which was to plant with no ridge. And the ridges were lowered at different moments, 30% like we had done in prior years, or 60%. And we will see what the impact of this will be every time the ridges were lowered. In the 2017 campaign, we see how the sprouts, both with mechanical and reduced mechanical and manual or simulated mechanical, which was a manual process but simulated the mechanical process, These sprouts per meter varied approximately between 10 and 20 sprouts per meter, which allowed us to reach an average of about 50 or 40%. We see that there was a very interesting amount of sprouts per furrow meters established. It's important to remember that the amount of cane that was used was about 15 tons in the case of commercial mechanized, and in the manual system, it was about 10 tons. We see in 2018 the different moments where the ridges were lowered, and with different densities, we were able to establish a similar amount of sprouts per meter, which resulted in between 9 and 10 sprouts per meter. In 2019, this pattern was maintained, and therefore, without ridges, with 30% of sprouting and 60% of sprouting, the establishment of sprouts per meter varied between 10 per meter and 13 sprouts per meter. So if you analyze the literature, the establishment of 5 or 6 sprouts per meter will not successfully establish a plantation under normal conditions. And here I would like to emphasize on the fact of why it's useful to apply the 30% criteria. As we can see in the image in the middle, 30% of sprouting allows us to have a certain degree of versatility and with a wider range of time to lower that excess of soil, because that excess of soil allows us to increase the soil temperature and homogenize sprouting. Many times we were able to successfully achieve a lowering to 60% of sprouting, but we have a smaller window to do this task. Because if there is any impediment due to weather, due to logistics, or transportation of the machinery, if we lose that window or we go over 60% of sprouting, this can cause damages in this activity called lowering of the ridges. So when we lower the ridges, since this is a cultural work that is done with mechanical equipment, this can affect us. Also, we have seen very clearly that in tests that were done without ridges, the sproutings were well established and in the same way as with the other methods, but we also saw winter weeds, and the lowering of the ridges, both in the case of 30 and 60%, allowed us to control those weeds in a mechanical way, especially winter weeds. Another important thing to take into consideration, and although these tests were done with no frosts and the conditions of the ground were quite optimal, in this year, 2020, we observed that when applying the criteria of not using ridges may affect the establishment of sprouts. I mean, they will happen, but they can be affected by the freeze, which is very typical in our area, especially in marginal areas where sugarcane is planted, and this may affect these sprouts as well as affect us in the establishment of that plantation. Ridges also allow us to preserve humidity. So lowering that ridge once the drought has passed, or that drought period has passed, allow us to manage the situation in a better way, and in turn allow us to better establish the plantation. Other parameters that were evaluated were, for example, the faults. These are very important points to be considered because we determine the percentage of faults, which is the meters of faults in 100 meters of furrows. We consider a fault basically when it's above 50 centimeters. There's literature throughout the world that consider a fault when it's 30 centimeters. We take into consideration the criteria of the stock. So 50 centimeters are considered a fault. We consider the average size of the fault, which is the centimeters, and then the frequency and how many meters we need to walk to find a fault. Here we are talking about destalking when we have a percentage of faults between 0 and 10%. We have an excellent quality of plantation, and 10 to 20% is the normal range. 20 to 35% is considered regular, 35 to 50% is considered bad, and more than 50% is really considered a very poor or a very bad plantation, and replanting is considered. Based on the parameters, we see here which were the results that we evaluated, and we see that in the case of 2017, where we compared mechanized planting systems versus manual planting, we see that we've been able to establish a very good plantation, and we were able to establish this system very well. We've had, in the case of manual planting, there were no faults, and in the case of values, the percentage went from 3 to 4%. So it was really good in terms of results and in terms of establishing the plantation. In 2018, this was also observed, mechanized planting with different techniques, and we see that the percentage of faults went between 1 and 6%. So this means that we were able to establish a very good plantation through this new system of mechanized planting. And in 2019, with the different alternatives, without ridge or with different moments when the ridges were lowered, and these different methods, no faults were observed, 0% in all cases. So what I want to remind you of here is that using planting densities of 10 tons per hectare, we are able to achieve a very good plantation with no faults. Finally, and to conclude my presentation, we see how the first slide on the upper left shows data from 2017, and we can see clearly how tons per hectare that were achieved in this system of planting. In comparison to commercial, we were able to achieve 70%, a little less with reduced mechanical, but with when comparing it to manual, we can see how well established the plantation is and how what good yields are observed in our plantations. In the lower part, we see how reduced mechanics showed better performance than commercial, and this, of course, brings about the fact that the use of more buds per meter is not necessarily related and does not necessarily affect a higher level of production. Like I said before, between 18 and 20 buds per meter, if this is well distributed, we are able to obtain a very optimal plantation. Finally, in 2019, like we see in the upper right corner, we can see that the use of the no ridge system, or with different moments of lowering that ridge, gives us a very good and well achieved plantation, maximum levels of production between 85 tons per hectare and minimum of 65 tons per hectare.
I'd like to make the following clarification here. The second ridging with a reduced density may have been affected at the ridging moment. That is, when we do not ridge down in a timely manner, we can cause budding damage, and this can result in less or fewer stalks on our sugarcane planting. But we do manage very good results, however, when we work with good criteria and in a timely manner, when we bring down the density and the timely ridging. So as a take-home message, in order for me to conclude with my presentation, I should say that in Tucumán, mechanical planting has made a great breakthrough. As Manuel duly stated out, there are growing numbers of planters who are coming into this new system for planting, and visible and invisible damage on buds are keenly caused by harvesting and transportation. It is for this reason, in my opinion, that I believe we should keep working on developing this new system, because there's lots of damage and we have to try to reduce it to affect fewer buds at the bottom of the furrow, and to use less tons of material, of this material that is so important. The seed distribution is heterogeneous at the bottom of the furrow. This has to do with uniformity in chopping. When we can regulate and have very good chopping uniformity and density, we can have better distribution. We can reduce the planting density without this having a negative impact on the final yield. This was shown on this slide. The ridging, reduced by 30%, allows us to minimize damage in sprouts, control weeds in winter, and preserve humidity. And one more point to consider is to walk away from a ground frosting, which is not a minor detail to consider in our area. And of course, we need good regulation and distribution of the seed. I would like to finally thank all the companies that have contributed for the possibility of this project, to all institutions, especially the experimental station that provides support for us to carry out these challenges, groups CREA and INTA, and all companies that managed to move this project forward, this interdisciplinary project between state-run and privately run agencies. Thank you again, and I'd like to thank the cooperation of the task force I am a representative of, because we keep moving forward, we face up to the challenges, and we take pride at the activity of growing sugarcane. Thank you. Good morning to the entire audience. I'm Juan Vallejo. I work at the sugarcane group of INTA Famaja at the agricultural sector of sugarcane. This project, it's a test of mechanized planting, was carried out together with CREA, Grupo Colombre, and INTA. We generated this synergy that is quite unusual for our sugarcane activity, I must admit, where we were able to empower the project thanks to the know-how of all players that participated in the sugarcane activity in the province. Let me jump into the topic. Let's talk about keys to the future of mechanized planting. It is important for us to see we're moving in the right direction into the future. We need to see where we got started, what the baseline was. In the province of Tucumán, our previous experience in mechanized planting was in 2008, 2010, when some companies started taking a bet on this system due to some difficulties, increasing difficulties in getting labor available and in planting seeds in a timely manner. So growers started mechanizing their planting efforts, and they came across a major difficulty. That is, in a given planting season, they saw lots of failures and faults in their planted areas. These faults at the time were kind of solved by increasing the number of seeds that we would broadcast per area without any other assessment in more detail. Of course, this showed fewer faults, and then growers or planters, when assessing the yield at the end of the cycle, achieved desirable results as compared to other type of planting. They did not see any productive differences between the two systems, and therefore the mechanized planting as a system went on a growing trend. But as planting got its zenith and then farmers adopted it more regularly, then they started rethinking a number of parameters and paradigms that had not yet been assessed under this system. And after a 10-year period where growers had used or had been using this system, we started analyzing with CREA the main users of these systems. There were quite a number of nuances that yet had to be discovered in terms of where we were going wrong and how the system could be improved. So the general purpose when we started the tests included trying to see what happened with efficiency in mechanical planting under the different scenarios of Tucumán and productivity in sugarcane plantations. Then more specific objectives came along to assess mechanical planting in the different conditions of the sugarcane growing area, different planting seasons in the Tucumán province, and growing densities, one of the main items to improve and be more efficient in consuming sugarcane. Aspects to consider in our assessment: the soil conditions, seed beds, planting systems, and different criteria on the different agricultural and ecological areas, the different time seasons, and as Juan Giardina already talked about, the ridging upon planting being a unique feature in Tucumán, because in the north of Argentina, there is no ridging method used upon planting. And then make a calculation of the final distribution, having considered all aspects. That is, basically, why to assess all these aspects? Well, the soil, it's a matter of knowing at each test and in every area what type of soil we were departing on, what the behavior of each soil was like, physical fertility, chemical composition, temperature, humidity, and a number of other factors that have an impact on planting. How we end up at the end of sprouting, this is the period where we focus our assessment efforts, and that was evaluated in our region. We didn't analyze it enough, and we needed to try to go further into detail to get its greater potential. As to the seed beds, well, the adequate management down to harvesting the bud, and a good planting system that would yield in excellent quality buds. As to the planting system in and of itself, well, we should talk about the bud harvester. We will call it a bud harvester from this point on, because we believe it is a tool where we can analyze damage and we can analyze some modifications to try and reduce chopping damage. It is key to consider all this in order to have better prospects in future planting, because a healthy bud will sprout healthily in the future. And as to the planting machine, we had to assess damage And we also have to assess distribution in the plot of land and how it behaves in the various areas. And criteria, management criteria, we'll get to see them as we move forward in my presentation. In connection to the soil, as has already been stated, there are different agroecological regions in the province with different soil, but we can say that sugarcanes like soils with an open architecture. We see a texture mix that is highly variable, and in some cases it varies where we carried out measurements. There were meter to meter structure variation, and this is seen reflected on results and on test errors that can be evidenced as we move forward on the various tests. This is how we can move forward. Another important factor are humidity conditions when planting, where we found that in this 3-year test period from 2017 down to 2019, where we assessed planting on a yearly basis, soil humidity conditions were close to field capacity when planting, and optimal conditions were found in every case. Well, a separate comment here. Conditions where we see soil in the sugarcane areas in Tucumán. We have a long background in production. There are pieces of land that have been used for sugarcane growing for over 100 years. So the structure of this soil is a massive structure. They lack structure by all means, and INTA has already determined this in previous tests. We see the effects of tilling and how to reduce transit and tilling effects to avoid compactioning. This is one of the key problems that we have in sugarcane plantations. Something that we've seen and that was considered as part of the protocol to follow is to get started in all tests with soil rotation with previous rotation. In our province, we tend to use soybean, as has already been mentioned by those speakers who spoke before me, but there are others that use cane on cane without cane on cane grown without any sort of rotation. So based on this, we made a qualitative assessment of how to render soil useful so as to find the right method for growers to define whether the soil was in the best condition to be planted or not. We assessed 3 ranges. Here we can see 2 photos. This is a good tillage and a no tillage of the soil. Good preparation with aggregate diameter smaller than 5 millimeters, regular with 5 to 10 centimeters, and a poor preparation with greater than 10 centimeter aggregates. The physical property of the soil, well, we see how they are altered when we till the soil, the structure, the density, and the soil temperature plays an important role as well when we consider humidity loss. So how do we consider how the seed bed is prepared? What about the sprouting effect, and what about the fault rate in the sugarcane plantation? Under poor tilling conditions, we had very low sprouting percentage. On average, it would reach 13%, and a fault percentage that reached 17%. When preparation or tilling was regular, this is an exponential effect. There are improved conditions, and then emergency or sprouting increases to 20%. And when there is a good preparation of the land, then when there is rotation, there is a sprouting that goes up to 44%, and fault is almost negligible because the rate is at 10% on the farrow. It should be stated that when the soil is not properly prepared, this happens under unoptimal or suboptimal situations. And these happen in cane-on-cane growing areas where soil conditions have excessive humidity. Some growers, just because they want to meet the planting schedule, just decide to follow the same procedures under suboptimal conditions when tilling the soil, and then the resulting outcomes or the expectable outcome is far from perfect. In connection to soil preparation, it should be stated that there is a rotation system where there is previous tillage or preparation. In Tucumán, we go through deep planting if necessary, and we then grow soybean, and on the next year, only on the next year do we decide to plant sugarcane. It should be stated that in our province, it is not a common practice to analyze the physical property of the soil, determining the structure of the soil, whether there are compaction layers or not, so as to carry out a good diagnosis and determine an adequate preparation of the piece of land. This is an outstanding task for growers. I mean, to carry out such a quality analysis that is fundamental when assessing this, that is preparing the land properly so that there is a successful growing and planting, especially considering mechanized systems, because since when planting a seed that is in and of itself quite tampered with because of its previous preparation for the harvester and the planter machine that works with a system of blades and other methods, then the stalk is highly damaged, so to speak, and there is a great loss of sugarcane weight because of dehydration. There's a lot of infection with soil pathogens, and more details that we will see through over the next few slides in my presentation.
This was, in a way, explained before, but we analyzed potential rotation in the 3 years where this analysis was conducted. It's interesting to mention that the quality of the canes that were used in all the tests that were conducted was excellent, excellent quality. Just to check, we did a potential evaluation done in chambers for sprouting with controlled temperature, 30 or 32 degrees, and a certain level of humidity, with substrates and with mixes of different substances that we used in these tests in a greenhouse. Over the 3 years, we observed in 2017, we applied a criteria for evaluation for potential rotation was for canes coming from a seed bed. We extracted the bud and we placed it and evaluated its sprouting. In the case of evaluating the seed coming from the machine, we extracted the samples and then did the plantation in small samples of the stalk, but the whole stalk. So there was a first year of the test where I observed that I had 90% of potential sprouting in the seedbed cane and 65% of potential sprouting in the canes coming from the harvester, the machine. So with this criteria to select the buds between 2017 and 2019, we unified the criteria so the buds that were evaluated only were those that were viable, that had no damage, and this is reflected in the results because the potential sprouting when using viable buds from the machine was showing these percentage of sprouting, and we did not see statistically significant differences between them. Regarding the issue of bud harvesters or cane harvesters, but we want to impose this concept of bud harvester. When we have an ideal size stalk with the least possible mechanical damage, this is what we want in order to manage the percentage of loss. In the 3 years of the trial, we observed in 2017, we saw machine 1, machine 2, and machine 3. So as you can see, the average of the size of the stalk changed very little from one machine to the other, 28, 24 centimeters when they are chopped by the machine. So the percentage or the number of buds was about 2.2, 2.6, 2.5, and so on and so forth. This pattern was repeated over time with a similar trend. The higher the size of the stalk, the higher the number of buds, or not, especially the number of buds per stalk depends on the initial condition of the plantation. If it was well developed, it has good temperature and good humidity during the growth period, we will obtain buds which, when it comes to chopping, it will give us a lower number of buds per stalk. So that is quite a random concept. But in general, we can say that the higher the size of the stalk, in general, the higher the number of buds. But that depends on the conditions. If our plantation has suffered from different stages of development, if it has a higher, longer stalks, it will have also a higher number of buds. We can say that in these trials, we saw an average size of stalk of 29 centimeters approximately, and a percentage of damage in the harvester of about 26%. This was explained by Juan Giardina as well. There is a percentage of invisible damage also, where it is not observed at plain sight, but it does depend on the conditions of the bud harvester when it was operating. Some growers have tried to improve their bud harvesting machine by implementing systems with rubber protections so as to protect them from the impact. But due to the problems during the harvest, all of these couplings applied on the machine did not really yield good results, because not long after it started using them, these rubber pieces started detaching themselves. So at first they may improve the performance and the percentages, but they don't last over time. In those cases where the systems are maybe 3 or 4 months in the going, they are not able to fulfill one cycle. As for the planter, during the 3 years that we analyzed, we used a we went from a mechanical system of distribution to a hydraulic distribution system. We decided to only work with hydraulic machines. Juan Giardina already mentioned this. The percentage of losses because of damage on the planter are neglectable. They are not significant, below 2 or 3%. In some cases, there were no damages whatsoever on the machine. But it's interesting to evaluate the distribution, because that was one of the failures that had been observed in the plantations, because in some sectors where no seed cane was being used, and the reason was that the cane had never been planted below the furrow. As a result, the companies developing the planters have shown an interest in improving their systems. And as we moved forward in the project, we started to consider all of the recommendations that came from the project. At the end of the project, we are now able to say that the distribution of the buds continues to have an irregular trend, as Juan explained. If we try to establish a frequency of buds with an ideal average that was established when designing the test, which was 40 total buds and 30 total buds with a commercial planting with reduced density. It's worthwhile mentioning here that we are talking about total buds, just like we were discussing the percentage of bud loss, and we were able to reach approximately 30 viable buds with high density commercial systems and 20 viable buds with a reduced density system. The most important thing here that we achieved with the hydraulic system was to not find any faults in the plantation, because the hydraulic system ensures a continuous flow of seeds to the furrow, and this in turn results in a lack of faults because of lack of seeds. With a mechanical system, for some reason, maybe imperfections in the land, this causes the machine to not function properly and, of course, result in faults in the plantation. So in this case, the manufacturer of the planters continues to work on improvements, and this is something to commend them for. Within the project, they are really thinking about the future and on a continuous improvement of the planter. They have added flow meters and flow sensors, and I think that in the future, probably the planters themselves will be regulating how many kilos they plant meter after meter, or at least every 100 meters, so that we can be certain that the planter will surely regulate, based on our criteria and in the best possible manner, the density of the planting or the number of buds that we want to plant per meter. As for consumption of seed cane, in these last years, it has enormous costs, and that's what we've observed. And as we evolved from a manual system to a commercial system, which can equal the conditions and avoid the faults that we had with a manual system, growers had gone from consuming 8 tons approximately per hectare of seed cane to 13.5 tons and sometimes even more. So this resulted in an increase of 63% of consumption of seed cane. And this, of course, affects the general costs of the plantation. One of the goals of the project was to reduce that level of consumption, and we saw that these results were obtained as we regulated the density of the planting. We were thus able to increase only 30% of the consumption of seed canes, and we were able to achieve a very good density. We applied different criteria, and this is what we've seen in the province. This is in the preparation of the soils, and we've prepared it based on good and proper diagnosis. That is the main tool, yes, to conduct a good assessment, to ensure the success of the process, and to ensure the relationship between soil and stock so that the cane does not suffer from losses or damages because of dehydration or other factors that may affect it. As for soil conditions, we evaluated temperature and humidity in the trial, and what we found when the highest percentage of planting takes place between June and July, the average temperature shown in this chart are the typical temperatures of Tucumán in the different agroecological regions in the month of July in this province. This is from 1972 and represents the temperature conditions in the moments where the planting is taking place. The temperature averages in this month in Tucumán and the changes were reflected when organizing the planting process. As we can see here in this chart, in May, June, in the Chaco-Pampeana grasslands in the province of Tucumán, we saw that the temperature of the soil in average at the time of planting was 12.5 degrees centigrade, and this is in line with the temperature of the faults. So we can say that at the time of the planting, the temperatures of the soil were reflected in the environmental average temperature. When we started the analysis, we tried to conduct a follow-up and a monitoring of the temperature throughout the sprouting cycle of the cane from planting to sprouting. But what happened was that there were difficulties in the interpretation of that data. But what we were able to obtain from this part of the trial was that the temperatures at the time of planting were similar to the average environmental temperatures that are usually considered for the province of Tucumán. If you can see in the depressed grasslands between June and July, when the planting takes place, you can observe that the temperature was 13 degrees centigrades, which is similar to this area in green. And August and September, that period in the depressed grasslands, we can see an increase in the soil temperature, which has to do with the fact that the temperature in the province starts to gradually increase. We see this map for this time. Other maps are not available, but we believe that it will probably go in line with environmental temperatures because we saw a coincidence during our analysis. The covering of the cane seed, as Mr. Giardina was explaining, is a very typical thing in our region. So as the project moved forward, we started thinking about new approaches and trying to establish new experiences, and the ridges or the lack thereof was very important when thinking about these processes. It is important to mention that in Tucumán, we use the ridging system in order to protect the cane seed when the planting takes place, because this occurs when the temperature conditions and soil humidity are not favorable for these crops. This is a cold time of year, and we have dry soils because of the rainfall patterns this time of year. They are subject to dehydration and, of course, loss of potential sprouting for the future. What we've observed in the last year of the trial is the fact that after applying all of the criteria, management criteria that we could use in this system of coverage or not of the cane seed when the planting took place. In this chart, what I'm showing is a test that we conducted here in San Agustin, where we analyzed the percentage of sprouting in the 2019-2020 campaign. Although we explained this quite well, the criteria for the first removal of dirt in the stalks established a percentage for viable sprouts, 3 or 4 centimeters. And the second process of destalking was 60% of viable sprouted buds with sprouts more than 4 centimeters. So we analyzed these different tasks, and we observed how in the commercial mechanized planting system with a density of 40 total buds, in the time of the first removal of the dirt from the stalks, we saw 40% of sprouting of sugar cane. We can say that between the first and the second process of destalking, we did not see differences regarding sprouting or the initial sprouts.
Here we can see on the light blue charts or bars this planting system without a border. This is a reduced mechanical system with 30 buds, and we see a high percentage of sprouting, 20-21%, exceeding the first and second dirt removal system, and then this high density buds as I'm highlighting here. It should be pointed out that there are some differences between the two treatment processes. These are due to the following. What we saw when covering sugar cane on the experimental lot that we have used, on the plots of lands that were assessed, commercial treatment with 40 buds without any ridge, we didn't see any good covering of the cane. And then we assessed that this poor covering performed when carrying out the test due to the machine may have come across harder or tougher parts of the land. I mean, the soil is highly heterogeneous. I'm referring to experimental plots of land, as I stated, had resulted in poor coverage. So this difference, we believe, is due to covering in this treatment in special had been kind of flawed. But these were the test conditions, and we continued it in this way down to the end. In mechanical planting with 30 buds, with a first and second dirt removal or growth promotion process, we saw this difference in sprouting initially and after. So our conclusion here is that, or we can say that when we treat with or without ridging, we don't see any significant differences. And in some cases, depending on conditions that have to do with soil preparation, among others, then we can conclude that in some agroecological regions in the province, we can plant without ridging. It should be pointed out also that the planting date is a key notion to consider and to define whether it is suitable or not to ridge, because if we focus on delayed planting where initial temperatures or baseline temperature conditions for each seed variety exceed the baseline sprouting temperature for each seed variety, then we can say that when planting we are already inducing sprouting. So is it suitable to ridge or not to ridge? Well, it is up to the consideration of each planter, depending on soil conditions and humidity conditions as well that are found in the piece of land when planting. This is something, a fine detail that has to be considered by each farmer, whether to decide whether they will be doing this with a ridge or without, because when treating these seeds without ridging, well, results were quite satisfactory as compared to the percentage of sugarcane sprouting. When we started the test season in 2017, we started uncovering this sugarcane seed, and we noticed that a lot of damage was found as they remained for longer periods underground, especially during the fall-winter time, where cane was underground until they would be destocked or until sprouting got induced on them. We started seeing damaged canes, fully damaged canes in some cases, where sprouts or buds had been negatively affected by pathogens, and even though they had started their initial bud and they might have grown up to 3 to 5 centimeters, in some cases they were seeing the surface, still the bud would die because they would be negatively attacked by soil pathogens. So during the first test year, we issued a warning. We started to see how we could go about improving the whole system so that the cane would not be so much damaged. In all the tests that we carried out during this 3-year period, at no point during the 3-year period did we douse or apply any protective material on sugarcane or any other enhancer to improve their budding. Everything would be done under regular raw soil conditions vis-a-vis the way we would plant them from the seedbed without enhancing it with any product. In real practice, this is not done in this way. All growers that use mechanized planting do enhance sugarcane with some product, even though when they may not be that sure what the final outcome of that product is or whether dousing this product is fully efficient, they still use these products in order to try and protect cane from ulterior damage. We initially tried and identify the pathogens that would attack seeds with the phytopathology team led by Sergio Perez Gomez. We carried out an effort where we extracted these seed canes from the soil after a 7 and 15-day period. And we saw how a colonizing process started on them. We saw how sections were cut. We carried out in vitro cultures, and we did cultures on them to try and identify pathogens affecting them. We identified quite a number of them under the Fusarium and Qualitatrichum genus. These are the main ones that we found on them, and we also came across this in the literature. They coincided with the pathogens that were affecting the seed cane that we were introducing on the soil. So once pathogens were identified, we performed a test of the phytosanitary product together with a number of companies and with the cooperation of CREA groups, because they were the ones that furnished the products. And we treated this under controlled conditions. And as can be seen on these beds, a fully effective use of this product was applied on these sugar canes. They were covered with this product for a few seconds to then be introduced on the pieces of land, and then they would be sent over to a chamber under controlled temperature conditions at 16 degrees centigrade, and they would be stored under those conditions for a 30-day period. We decided what the infestation surface was of each stock for a 30-day period. We assessed the treatment, quite effective treatment, even though it was not fully effective in all cases, and we also assessed low effective treatment that did not manage to remove the pathogens from the stock. Based on this, we issued a number of recommendations on the number of products that best performed in protecting sugar canes and that are widely used today. Another item here was to apply these products in planting. Efficiency in planting this on sugar canes on the planting furrow, so to speak. We still did not assess all the products that we had used for the project, for the entire project, because we came across a big problem in soaking sugarcane when planting it. We worked with these little stalks. They were attached hydrosensitive labels on their cuts, and we tried to estimate a percentage, a soaking percentage, to see what the level of soaking was on each of the stalks to determine a very low soaking percentage, less than 40%. These data are yet not conclusive because we would very much need to keep testing on this. we can still define soaking methods, because we get to see that even though the product is highly effective, if we don't soak it properly, then results will be far from satisfactory, will be far from perfect. So one of the items we'll keep working on is to try and have other interdisciplinary teams join our effort, where they can focus. I mean, we will call upon specialists soaking phytosanitary products, so they can cooperate and help us improve how we soak these products to the stock. This being so important in order to improve budding performance rates and to keep reducing the number of seeds used for planting. Finally, I should say that in the various regions and on the various tests, we estimated production based on all the treatment alternatives that came about over this 3-year period, considering the manufacturing performance and the crop performance. Manufacturing performance at no time did it have any significant effect on the planting system that we may have used, as opposed to expected results. And as to the crop performance in and of itself, well, the various approaches that we managed to have after the 3-year period, with early dirt removal or at a later stage or directly without a ridge, well, the production of sugarcane per hectare did not show any statistically significant difference. Therefore, we can say that during this period, 2019-2020, there is no contraindication. That is to say, we cannot say, let's work without a ridge. I mean, growers can choose among all 3 systems, and I believe that all 3 results would nonetheless be quite satisfactory, as had been stated before, based on the criteria that we have presented on soil preparation conditions, humidity conditions, and the time of the year, the season. So what about the keys? Every grower will have to determine what their planting key is, and this key will be determined on technical criteria on each and every one of them. But all of this will be based on information that got generated over this 3-year period. With the project, where we believe there will be a lot of information, a wealth of information for all planters in the various areas of Tucumán, where a number of different conditions were found for production purposes, and with very satisfactory results across the board in all cases. Thank you very much for your attention. I'd like to thank my team, those that have cooperated in all tests, in statistical analysis, in logistical support, Perez Gomez, Julio Sainz, providing support in assessing, Mr. Felipe, the engineer in the sugarcane group, in collaborating with logistics to carry out this project. Thank you very much. Thank you very much for those that have joined later. This is the second module of this workshop. My name is Esteban Brito, and the purpose of my lecture is to talk about the experience of the Balkan company in consideration of mechanized planting. I'll try to be brief in my approach. In connection to experience, for the last 10 years, we've been working as a company, and we haven't been working in a continued manner, but already since 2010, we planted our first 50 hectares in a mechanized manner with a locally developed planting machine. In 2014 and 2016, we had successful experiences by using the distributor as a mechanized tool, and already in 2017 we decided to incorporate our first hydraulic automatic planter. On that year, we planted 580 hectares, and that was the year where we got started with this project. So we jumped along and ahead with the project. And our purpose today is that 30% of our planting, that is, this would be 1,500 hectares, they should be planted in a mechanized manner. Without any doubt, the whole thing is nothing but an exchange of experiences and of lessons learned. I was asked to talk about what, in my opinion, in our opinion as technologists, the contribution is by the mechanized planting project. And I will summarize it in a phrase. It's a different outlook, the other outlook on things. This is so because when we started with this idea, the need to assess this technology, we asked the team of our researchers to know what the damage was caused by the planter onto the seed. And it turned out that the first few results showed that the harvesting is the one that causes greater harm. So all the eyes were turned onto the harvesting point in order to modify whatever was necessary to minimize damage. In connection to buds, again, the question was how many buds per meter are ideal to have? And the answer is the most important thing is to have a good distribution. If you manage to have a good distribution, as has been very clearly stated in the workshop so far today, only then can you bring down the amount of buds per meter. Together with the project, we managed to bring it down by 25%, meaning the number of buds that we currently use in our planting, in our mechanized planting efforts. In connection to the entire operation, we've increased by 130% our operation in this entire process from 2017 down to 2020. And this is due to all of those that were part of the project. This is thanks to them and thanks to companies that had been asked to join a CREA meeting where we talked about the problem that we were having at hand, a productivity problem that we wanted to solve. We currently have a planting average because we have two mechanic planters. We have a planting average per machine of 7 hectares per machine per day. In connection to soil preparation, I won't delve into the details, but I should say, however, that we need to be demanding on the entire surface to be planted. The soil has to be very well tilled or prepared. In reducing ridging, as has been mentioned quite profusely in this workshop, this is because this has been a major contribution by the project. And this is because this used to be a technique that had no criteria. I mean, each person would do this when they deemed suitable according to their own objectives. Currently, we do some monitoring of the plots of land where ridging is to be performed and based on budding criteria, not emergency buds. I mean, this should be clear, between 40 to 60% budding. For the last 2 years, we have been carrying out this task of de-ridging, and this is not only in mechanic plantation, but in all of our plantations, actually.
The most important thing that the project has brought us is teamwork. Without a doubt, this teamwork has become the model to be able to address one of the major problems of the sector. And this is very admirable because, as you have probably seen, and as Fernando has also mentioned, the idea is to work with the institutions, with the productive sector and the private sector, which all have supported this process. This involved certain assessments that we had made but of course, really digging into the land, measuring, and really coming up with very solid information and a criteria for decision making. This is very important in this sense. And of course, how important it was to have a different perspective to really come up with solid information, which is now being shared in this virtual event. In this slide, this is more of a personal view. Of course, any activity has advantages and disadvantages. But it is worthwhile discussing these things from an operational logistics perspective, also in terms of sustainability and energy consumption. Also, in terms of cost, there are some companies that consider that mechanized planting is more costly. For our company, it is less costly than engaging in manual planting. Just to briefly describe this issue of costs, I can say that if we divide the cost of the planting into three, since because of the demands, it will probably be more costly when done manually. Because in terms of cane seed, we are using on average 3.6 tons more per hectare than with manual planting. And this is only the result of the adjustments made because of the extra damage caused by mechanized harvesting. This increase in the use of cane seed increases the global cost of the plantation. But our great savings lie in the workforce, in the labor costs. Right now, we have a replacement rate of 1.7. This means that the daily furrows and the performance of our planter, one person who is working in the mechanized plantation system is replacing 7 people in manual planting. So what I mean by this is that we have to agree, we have to engage in the discussions that are necessary, but I think that we need to create a tool, and when sugarcane producers implement the system, it should yield the best possible results. Finally, a recommendation. This is a very clear recommendation, which is to fully control and monitor the activities. Every day while we are doing our activities, there is a person who is doing between 6 and 8 samples per day. This person analyzes the distribution, the number of stalks, the number of buds per stalk. This is important as well, the length of the stalks. And it has become fully clear that this is directly related to a good distribution. And of course, also a categorization of the size of the stalks. And we added date, variety, etc., and all of the information possible. This is done on a daily basis. And for us, it is very important to have this information because based on this information, we can make decisions. As the different planting seasons move forward, the conditions worsen. If you see the image, you can see a very good distribution. Undoubtedly, an appropriate number of buds. But if you observe the humidity of the soil, it is very dry. So it is very important to control and monitor all activities to ensure that everything that is measured, that everything is measured, because everything that can be measured can be improved. That is all. I would like to thank you. I remain at your disposal for any questions, and I would like to thank my work team, and thank you for your attention. Thank you. I would like to thank the three speakers who discussed mechanized planting. I'm sorry to say that we will not have time for questions. It's a shame, really. There are many questions to be answered, but we just would like to clarify one thing. This lowering or this reduction of the ridge, and this applies, the question applies for commercial and for mechanized planting. In the area of Tucumán, we create like an initial bed of soil to cover the cane and protect it from frost. And what we do with this lowering of the ridge is, in a way, removing that soil to allow the temperature to arrive at the sprouts and to not cause an excess in demand on the sprout. So basically, that's what bajada de bordo, as it is called in Argentina, or the lowering of the ridge, takes place. And we always try to compensate a bit, and reduced planting seeks to reduce precisely the amount of buds that are planted, and it comes closer to a manual system. It is more similar to a manual system. I apologize because we have to eliminate the exchange with the speakers. And I know the audience is very interested, and there are many, many questions. So we'll try to respond to those questions maybe through other channels. I would like to thank everyone for their interest. And once again, I apologize because we do not have time to answer all of them.